Hello, I am Oriane Dermy and I am going to present my work entitled Using Behavioral Primitives to Model Students' Digital Behavior. So the goal of the work is to represent the behavioral dynamics of a group of students. Here is the overview of the whole work, and we will see step by step this work. And our particularity is the last part with ProMPs, which is a dynamic representation of learning's behaviors. So first, we take the Open University Learning Analytics dataset, OULAD, which is open source and fully anonymized. We selected a course of science with 1,300 students, and the course have a duration of 240 days, with 20 activity types and 14 exams. From this data, we had to select learning indicators to represent the behavior of students. To do so, we used the work of Selina Troiler in 2021, where she computed 5 learning indicators: engagement, performance, reactivity, curiosity, and regularity. And she created 4 subdatasets, 1 per final grade, composed of the most representative students. For example, for the distinction student groups, she selected 86% of the students, which correspond to 53 students. In our case, we use the same subdatasets with 3 learning indicators. And we look these indicators evolving over time. So the engagement, which corresponds to the number of clicks, this performance, that corresponds to scores obtained in the assessments between 0 and 100, and the reactivity, which corresponds to the delay between submission date and deadline. And from these trajectories, we have a group of trajectories for a group of students, and we want to represent the distribution over these trajectories. To do so, we inspire ourselves using movement primitives, which is a well-known approach in the robotic field, where there is a lot of algorithms that exist in this approach, like hidden Markov model with timing to represent letters, time invariant Gaussian mixture model to put objects in a box, and dynamic movement primitives that allows, for example, a robot to perform movement correlated to the movement of the human. And in our case, we focus on probabilistic movement primitives that allows robots to learn by imitation, to play complex games that require precision, and to play maracas, which require rhythmics. So the probabilistic movement primitives model is quite complete to represent complex movement. This is why we select it. It has been created by Parashos in 2013. So we apply this method on the e-learning field. About the model, the goal is to represent a trajectory, here in 1 dimension to be simpler. And to model this trajectory, we use Gaussians spread over time. It could be also over radial basis function. So we put some weight on these Gaussians to fit the model to the trajectory. So here is a pondered Gaussian. And when we combine them, we obtain the trajectory in red. So here the precision of the trajectory is not really accurate, as you can see. And more we add Gaussian, more the movement will be accurate, as we will see after. So the first step is to compute the omega vectors of all trajectories. So here each color corresponds to 1 trajectory, and we have 11 weights for 11 Gaussian of the model. So to fit this weight to the data, to the trajectory, we use a regularized least mean square with the Tikhonov regularization. Then we learn a distribution over these omega vectors with a mean and a variance, expecting that it follows a normal distribution. Then, thanks to Gaussian computation, we have a trajectory distribution. Here is the kind of result we have. So on the left part, we have the real data, and on the right part the pro-MP, which correspond to a mean in bold line and a standard deviation in the shaded area. Each line corresponds to a learning indicator, the engagement, performance, and reactivity. Here in blue we represent the distinction student group, and other color will correspond to other groups. As you can see here, the trajectory represents the global shape, but is not accurate to the data. If we add Gaussians, we change the granularity of the model and we can tune the model to the trajectory. But in our case, we focus on the general trend of students. So here is the result, in blue for the distinction group, green for pass student, red for withdrawn student, and pink for failed students. And we can see that pro-MP succeed in representing the global tendency of students' dynamical behavior, which is visible and interpretative. Make an attention about the engagement indicator. Even if we have the same kind of shape, the scales are different because students who pass or have distinction are more engaged than students who withdrawn or fail. About the withdrawn group, we can see that from the first exams, the mean and the standard deviation of the engagement is near to 0. But at the beginning, we can see that all students groups were engaged. And before the 90th exam, we can see a peak of activity for each group minus the withdrawn one. About the performance, we can see that distinction and pass groups are quite stable, but decrease after the 90th exam. Maybe because it's a complex skill. We can also detect an indicator correlation between performance and reactivity, because we can see a kind of symmetry between this dimension of the pro-MP. So another result consists on overlapping each distribution to see specificities. And thanks to this overlapping, we can identify two tendencies. The first one is composed of the pass and distinction groups, where the score average is steady and high, and the delay average is close to 0. The big difference between pass and distinction group are the variance of the performance indicator, which is really higher for the pass group. The other tendency is composed of the withdrawn and failed group in red and pink, where we can see that the score average fall to 0 and the delay average increased up to 240, which is the maximum because it is the duration of the course. The big difference between both is the slope is steeper for people who withdrawn. About the engagement, we can also see here that at the beginning all students were engaged. For the fourth exam, fail and withdrawn groups disengage, with a mean that is at 0. And for the 90th exam, distinction and pass groups made extra effort. However, the variance of the pink fail group in pink is upper than the mean of the pass and distinction group, showing that a few failed students also made effort for this exam. The last result consists on detecting behavioral specificity of a given student. So in dot line, we represent the trajectory of a student who fail in pink and who pass in green. First, we can see that the trajectories of both students are inside the distribution. However, if we compare with other distribution, at some period, the behavior is similar to another group. To show that, at each exam date, we put a big point with the color of the distribution which is the nearest. And we can see that at the beginning, the failed student is close to the pass group. And the pass student is close to the distinction group at some point in blue. So we think that motivational help could potentially be fruitful. For example, teacher could give encouragement for the student who begins to pass from the pass group to the fail group in the blue area, or for the student who begins to have a distinction group behavior. So, as conclusions, the advantages of the ProMP's model is to visually represent the evolution of data over time. It guarantees the anonymity of learners because we represent a group of learners and not one learner by one learner. Since it's a probabilistic model with a distribution with mean and variance of data evolution, it opens up a wide field of research, as we will see after. We have seen that the precision can be changed to represent either the general trend or a precise evolution of the data. We have seen that we can compare the evolution of different datasets by overlapping the distributions. Also, we can detect students' behavioral specificity, as we have seen just before. As perspectives, we want to statistically estimate the future students' behavior, to generate trustworthy and artificial data, to develop tools for teachers and study their impact in real-life situations. Thank you for your attention.